Hi, everyone. Looks a little weird, huh? For skill 3, we are going to start implementing our graphing calculator. Now, if you don't have a graphing calculator, and you are not going to get one, there is a free extension for your Chromebook. Just email me and I will send it your way, okay? For now, pause if you do have a graphing calculator and go get it. All right, so for example number 3 under skill 3, it wants us to graph the following. So if you haven't turned your calculator on right here, and then up in the upper left-hand corner, it says y equals. If you press that, this screen comes up. Well, actually my second button was clicked and that's not what I want. So second quit, take me home. Okay, y equals, there we go. This is what you should see. And we're gonna put in the equation negative x squared plus 6x plus 3. Okay, first thing, be careful right here. That is a subtraction sign. We do not want that. So I'm going to go on top of the subtraction sign and hit delete. I want the negative sign, which is down under the 3. So negative x is up under mode right here. The squared button is to the left, or you can use the upside down caret right there and press 2. But if you use this button instead of the squared, you'll have to arrow to the right to get down out of the exponential spot, and that's okay. Plus 6x, which is up under mode again, and then plus 3, and enter. Now, the nice thing is you guys can see my key history down here, so if you're lost, okay, just look at that again. Sorry. So then I'm going to go up to the upper right-hand corner of my keypad, and I'm going to hit graph. Ah, very nice. It is beautiful. It opens down, which is what we need. X-intercepts and vertex is what we're looking for. Okay. So as I go through this, please, please, please write down on your notes because it says value from your calculator and how did we find it with the keystrokes. Okay. We can't see the vertex, but that's okay. I'm going to hit second trace because that function up there in blue is a second function and it's going to allow me to calculate all these values off a given graph. Now I know my vertex is a maximum because it opens down and I can see that it's a maximum. So I'm going to go to maximum and hit enter. It's now going to ask me for a left boundary. So I want to be the left of my vertex. There isn't a specific left, just left of your vertex. I am, so I'm going to hit enter. And then it says right boundary. All right, so I'm going to arrow to the right until oh, there I am. Am I to the right of my vertex? Yes. So I'm going to hit enter. Now it's going to ask one more time, is this where you want me to guess? Yes, it is. So I'm going to hit enter. And at the bottom, it's going to tell me that my vertex is at 312. Now I know it says 3.00003. We round that to 3 because it's doing the best that it can. And I did kind of give it a wide area. So that's okay. So that is our vertex at 3,12. Well, we're going to do a similar process for our intercepts. We can see, I mean, my guess is it's negative 0.5, but I need to find exact. So I'm going to hit second trace for calc. And remember, your x-intercepts are your roots, your solutions, your zeros. So I arrow down to 0 and hit enter. Now it says left bound again. Well, I don't see my cursor, but I know that it's at 312. So I'm going to arrow to the left until, oh, there it is. And I'm going to go down and I'm going to go below the x-axis because I need to be to the left of the x-intercept that I'm searching for. And I'm going to hit enter. And then I'm going to go above the x-axis because I need to be to the right of the x-intercept that I'm searching for. And I'm going to hit enter. Look at the two vertical lines. Is your x-intercept in between this? And I'm going to hit enter one more time to verify. And my calculator tells me that yes, it is approximately negative 0.5. I'm just going to round to the tenths. All right, we got one more. So second trace, and I'm going to go to 0 because I'm looking for my x-intercept. Hit enter. I need to be to the left. Well, shoot, man, it's all the way over there. So here we go. I'm going to arrow to the right. Am I to the left of my x-intercept? Yes. So I hit enter, and now I need to be to the right of the x-intercept I'm searching for. I am, so I hit enter. The vertical lines show me the areas that I have set as the boundary for the calculator to search. And again, the reason why we have to set these boundaries is because this is an infinite set of points. It goes on forever. Your calculator will not search the entire graph. You have to narrow down the search for it. So is this the region that your x-intercept lies within? I press enter to say yes to my calculator. And it tells me that this one is at approximately 6.5, 0. Now, let's say you wanted to see your vertex. You could zoom out. Up in the top row in the middle is a zoom. So I could hit number 3 for zoom out, but I need to give my calculator an area for which to use for reference. So you move your cursor. When you're ready, press enter, and it will zoom out a little bit. I'm not a huge fan of this because, as you can see, it's got a lot of small tick marks. It really zoomed out. So you could, in the top row, click on window, and you could adjust. So maybe I want my minimum x-axis value to be a -5. I would like my max to be 10. Let's say the x scale is I want each tick mark to be scaled 1 unit. I'm going to leave that as is. X minimum, let's say I'm going to go -10, and then X max, I'll go 20. Why not? Still X or the Y scale 1 unit. So now when I hit graph, ooh, that's beautiful. That's a much nicer window than when I zoomed out. So window is definitely the place you want to go. So back to our note guide, now that we've graphed, we found that the vertex was 312. And hopefully you wrote down the keystrokes to remind you when you do it on your own. The x-intercepts we found were -0.5 and 6.5. And again, the keystrokes, the calculator notes are for your reference, okay? All right, so based off that information, we can easily find the axis of symmetry because we know it's x equals h, so x equals 3. We know there is a maximum value because it opened downward. It had a vertical reflection. So maximum value of 12, there is no minimum. Our domain, because it's a parabola, the x values aren't restricted. So it's all real numbers or -infinity to +infinity. And the range, since it is a vertically reflected parabola, is going to start at -infinity and stop at the maximum. So we say y is less than or equal to 12, or it goes from -infinity to 12 inclusive. Sweet. So your calculator, and notice you guys, it says as a tool, not the end all be all. Okay, your calculator is a resource to help you. Are you doing it the right way? Did you make a mistake? Okay, use it to verify. Don't use it to think for you. And that's something we find our students fall into the trap of. They let it think for them. All right, so let's take a look. Now, on Monday, we looked at all 3 different forms of a quadratic. Right now, I can see that this is in standard form. I have an A coefficient, a B, and a C. If ever you're missing one of the coefficients, such as maybe there isn't a B term, then you would just use 0, okay, for those. And we need to find the vertex and the axis of symmetry. So remember from Monday, in order to find the axis of symmetry, and that is always where we will start when we are asked to graph in standard form, we use the ratio of -b over the product 2a. So negative, I'm going to substitute in our b value, which is -16, all over 2 times a, and a is 4. Keep simplifying with me, please. We get a positive 16 over 8, which is 2. So the axis of symmetry, feel free to write AOS, axis of symmetry, is going to be x equals 2. And we know that the axis of symmetry shares the x coordinate of the vertex. So I'm going to write V for vertex, and it's 2, some value. Well, as mentioned on Monday, in order for us to find the corresponding y value, we take the value found with the ratio and substitute it into the given equation. So y is going to equal 4 times 2 squared minus 16 times 2 plus 10. Order of operations says we do exponents first, so 4 times 4 minus 16 times 2 plus 10. I'm then going to multiply, so I get 16 minus 32 plus 10. Again, order of operations. Addition and subtraction we complete from left to right. So we get a negative 16 plus 10, which simplifies to negative 6. So our vertex is at 2, negative 6. Excellent. Okay, so on our graph, I'm going to go to 2, 1, 2, 3, 4, 5, negative 6, and there's my vertex. But I need more than just one point in order to graph. In order to find another point, you're going to have to pick an x value that is close to the axis of symmetry location. I'm going to say it one more time because you need to write this down. You need to pick an x value that is close to the axis of symmetry location. And the reason is this: if we're graphing a quadratic, it's growing exponentially, super fast. So if I have an x equals 2 axis of symmetry and I pick 7, holy heck, my y value that corresponds to x equals 7 is going to be quite large. You're going to be mad at yourself because you're not going to want to graph. So in this case, I'm going to choose 1. And I'm going to take 1 and substitute it into the equation for all x values and simplify. So 1 squared is just 1 times 4. And then we get negative 12 plus 10, which is negative 2. So I have an additional point at 1, 2. Oops, negative 2. Don't forget the negatives. Ay, ay, ay. Okay, so 1, negative 2. And then, because this is a symmetrical graph, I'm going to reflect that point across the axis of symmetry. Yes, you're allowed to do that. But I would like you to have a minimum of 5 points, please. Yes, write that down too. A minimum of 5 points, please. So I'm going to choose 0. And I'm going to substitute that into the equation. So 4 times 0 squared minus 16 times 0 plus 10. 0 minus 0 plus 10. So we have a y-intercept of 0, 10. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And I'm going to reflect that. It's 2 spaces to the left from the axis of symmetry, which means that it's going to be 2 spaces to the right as well. Wait a second. Your y-intercept is 10, right? What else do you see that is 10? Oh, ladies and gentlemen, this is awesome. Yes, your C value, this guy, will always be your y-intercept when you are given an equation in standard form for a quadratic. Big smiley face, write that down. Your C value is always your y-intercept, and that makes sense because, yes, I have a quadratic term with an x, an input, right? I have a linear term with an input. So if I substitute 0 in for x, those terms go away and you're left with the C value. So if you are given an equation in standard form, your C value will always be your y-intercept. You're welcome. All right, example number 5. We have a model for the performance of a stock. Model is referring to an equation. Okay, if you model something, you're writing an equation to represent the behavior of that situation. And it is P equals negative 3D squared plus 50D. Now, D is representing the days of trading, and P is the price per share. What is the maximum price per share? So we are looking for the maximum price, which is P. Well, gosh, if I think about what this model looks like on a graph, It is a negative, well, first off, I know it's a quadratic because it's squared, right? And it has a negative a value, so it's going to look like that. A value of a negative, sorry. So where does the maximum occur? At the vertex, yes. We know how to find the vertex because this model, this equation is in standard form. So first, we would find the axis of symmetry. X is equal to negative b over the product of 2a. So I substitute in 50 for b. Perfect example. There's no c value. That's okay. That just means c is 0. So technically that would mean that I would be intersecting right there. Since we talked about the c value being the y-intercept. There we go. Okay, so negative 50 all over 2 times a, which is negative 3. That leaves us with 50 over 6, and I'm going to reduce that to be 25 over 3. Now, 25 thirds, that represents the axis of symmetry. This right here, that represents D, because you'll notice D is the input. So this represents the days of trading. However, that's not what we're being asked for. We're being asked for the maximum price per share. So we need to take the 25 thirds and substitute it in for D. So we get negative 3 times 25 thirds squared plus 50 times 25 thirds. And you'll notice I'm not putting it into decimal form because I need an exact answer. I can approximate at the end, not in the middle. And it's at this point that I absolutely recommend you use your calculator. Pardon me. You can plug it in all at once. Be careful with the fractions. Okay, fractions are division, so you might have to put 25 divided by 3. But when you do work it out, you get that the maximum price per share is approximately $208.33. Now you can round. It's appropriate. We were being asked for the money, right? What's the maximum price per share? So we are required to round appropriately. Sweet. Nice job, guys.